Okay, so this one's a little harder, so put a star by it. You'll want to refer back to it because it's got a couple of things in here. So first, let's get it in standard form. So that means we need to divide everything by x, correct? So I have y prime plus 2x minus 3 over x, y equal 4x cubed, right? And so I'm just leaving it like this. And I divided by the x and got x cubed over here. All right, so let's make our integrating factor, which is e to the integral of all of this, 2x minus 3 over x. Okay, so in order to take this antiderivative, I'm going to split it up. So I have 2x over x, so that's 2, and then negative 3 over x. Two terms up there. Okay, so taking the antiderivative here, I get 2x. Okay, so with this, you know that this gives me a negative 3 times the ln of x. Okay, so this is one of the big things here. So first off, I see this subtraction up in the exponent, so I know this can be broken up. So I have e to the 2x times e to the negative 3 ln of x. Right? Okay, so that's one of the big things, is breaking it up. Addition or subtraction in the numerator is multiplication downstairs, right? Right, not in the numerator, in the exponent. Addition or subtraction in the exponent is multiplication down here. Okay, this e and this ln need to cancel, but I have to move this negative 3 first, right? So I'm going to say e to the 2x times e to the ln of x to the negative 3. And again, for reasons I'm not going to worry about explaining, you can eliminate the absolute value on the x. So this exponent has to come up. And so now the e and the ln will cancel. So I get e to the 2x times, and I just get x to the negative 3. And I just like to write things without having negative exponents because it helps me when I move forward. So this is my integrating factor. Okay, so this is what I multiply both sides by, or everywhere. So let's do it. So e to the 2x over x cubed y plus e to the 2x over x cubed y, and then I'm going to cancel the cubes, right? If I multiply this by this, the x cubes will go away, so I'll just be left with 4 e to the 2x. Okay. Whew. Remember, what's supposed to happen over here? This is supposed to be, right, this left-hand side here is supposed to be the derivative of the integrating factor times y, right? Okay, so, oops, I dropped my prime, didn't I? So there's a prime there, and I just dropped it. Okay, so here we go. So there's first d second, plus second d first, right? So let's just go take the derivative of this thing, right? Let's go take the derivative of e to the 2x over x cubed, just over here, just to make sure that it turns out to be this, right? So in order to take this derivative, you need quotient rule. So that's low d high minus high d low, and then squaring the bottom. So squaring x cubed gives me x to the 6th. So let's see if I could factor out an x squared and an e to the 2x, right? So what's left in the numerator here? I'd have 2x minus a 3 over an x to the 6th, and if I cancel the x to the x squared and x to the 6, so I get e to the 2x minus 3 over x to the 4th. Okay, is this what I have over here? Look at that. That is exactly what that is, right? It is. Okay, so it does work. I just wanted to kind of verify it worked because it's a little harder one, right? All right, so then, oops, didn't mean to use red. Okay, so here we go back. Okay, so now, I guess now I want a different color to say I'm going to take the antiderivative of both sides, and on this side, the derivative and the integral cancel each other out, so I just get e to the 2x over x cubed. Sorry, it's kind of messy. And then I'm going to take the antiderivative here, so I carry the 4, do a little Hoyle theorem, so I get e to the 2x divided by 2 plus a c. All right, so now this point right here, again, is the easiest place to solve for the c. So let's go put in x equal 1. So I'd get e to the squared, right, x equal 1. And here I would get 2e squared plus c. What did I do? I lost my y. Oh my goodness. Okay, silly me. All right, stop. Okay, so when I took away the derivative in the integral, I should have this whole term, right? So there's the y there. All right, so now I'm plugging in x equal 1, y equals 0. So this side is 0. Now I'm plugging in x equal 1, so I get 2e squared plus c. So that means c is equal to negative 2e squared. So then e to the 2x over x cubed y equals 2e to the 2x minus 2e squared. And it is necessary, if you can, to solve for y. So to solve for y, I'm going to multiply both sides by x cubed over e to the 2x. And there's my answer.